Lesson 1.2b, change of base and log regressions. So here's our log regression steps that we've already taken a look at when we did our exponential regressions. Same steps, here they are if you forget. And again, if step 4 brings up a different screen, there's the section what to do if this screen comes up. You follow these steps here. Okay? Let's take a look at an example. Here's some data. Put those into list 1 and list 2. Do a log regression on them, please. Round each parameter A and B to the nearest thousand. I'll give you a couple minutes. Push pause now and play when you're ready. Okay, so what you should have got is you would get A is equal to 8.84785 and so on. B, you're going to get 9.6036 and so on. So if we want 1,000, that means we want to round to 3 decimal places. So we look at that next number and see what it does. In both situations, it's going to make us round up. So I'm going to write my equation as A, or Y equals, our A is 8.48 plus the B, 9.604. And then I put my ln x on the end, and I'm done. Okay, there's your equation. Let's move on to the next example. Okay, so how do we actually input logs into our y equals in our calculator, or evaluate logs using our calculators? Well, first of all, our calculators are only base 10 or base E. So in that case, we have to graph non-base 10 equations in the following way. We need to actually convert them. We're going to convert them to base 10. So what that means is we need to divide it. So what we actually do is we're going to take the log of the argument and divide by log of the base. So if I take a look up here, my argument is my x. So I'm going to take log x on top. And my base is a 2. So I'm going to take log 2 on the bottom. I instantly divide them, and that's how I change to base 10. When there's no base and it's hidden, these are each base 10s, just like our calculator does. Okay? Are the brackets necessary? Absolutely, yes they are. Okay, but what if we have 2 different log functions and calculator buttons on our calculators? We have the log button and the ln button. Well, let's investigate both. We're using our log button. Log button is base 10. Okay, that's the big thing with our log button. So they're showing another example here. Log base 10 of x would be log x divided by log 10. Or simply log x, because our 10 can hide. With our ln is the same type of thing, only it's a different button and it's a different word. So it's a base E as well. It doesn't use base 10, it uses base E. And we know that E exponent 1 is a run-on decimal, like pi. Okay, it's an irrational number. So what we do is we do the exact same thing. We're going to take our argument and the log base of our argument on top and divide by log base E on the bottom. Now, when we do that, log base E of x is the same thing as saying ln E of x. Now, do we need to put that little e there? No, we don't. It hides, just like our 10 hides up here in log. Let's see what that looks like. So our example is log E of 15. It's often written as ln 15. Because log base E is the same thing as saying ln. So everybody type in your calculator ln 15 and see what you get for a decimal. You're going to notice you get 1.60943 and so on. They run on forever. Now I want you to use the change of base feature and do the same thing, only you're going to have to do change of base. So type in log 5 divide by log base E. Now E is going to come up with a blinking exponent part. You must put the exponent 1 there for it to actually be using the base E. So now just take log 5, divide by log E exponent 1, and you're noticing you're going to get the exact same answer. So that means that if we have log base E, it means the exact same thing as ln. Okay, that's what it's proving to us. Let's try the other example here. I've got ln E. Well, just like our same base and argument, this is the same as me saying ln base E of E exponent 1. Well, when my log argument and base are the same, they cancel. This should give me an answer of 1. What I'd like you to type in your calculator, hit the ln button, then hit your E button, which is second ln, and put exponent 1 on it and enter. You're going to get the exact same answer of 1. Okay? Alrighty. Let's move on to the bottom part of this slide here. It's asking us, how do we order log expressions? So if I want to order them and put them from least to greatest or greatest to least, whichever it's telling us, we can use a strategy. We can do change of base, and we need to solve them and put them in decimal form. Okay, we need to solve each of them and put them in decimal form so that we know where they are on the number line so that we can put them left to right. So I'll give you a couple minutes to solve each of those and then order them left to right, least to greatest. Okay, give you a couple minutes, push pause now, push play when you're ready. Okay, you've got a couple minutes. When you take a look at this, this is going to give us, as I said, this is going to give us for the first one an answer of 0.3 repeating, which is 1/3. Then I take the second one. This one's going to give us an exact answer of 1. I take the third one, and I'm going to get an answer of -3. I take the fourth one, I solve that one, and I'm going to get an answer of, oh goodness here. Okay, I found it. It is exactly 1/2, so 0.5. 1/2 or 0.5. We take and we solve the very last one here, and we're going to get -1.5. So now that I've got them solved, I can put them in the correct order. So the correct order from least to greatest would be this. We're going to have our -3, our -1.5, our 1/3, then our 1/2, and then our 1. That is the correct order. So back to our change of base. We see this is what we call the change of base identity, what we were talking about, changing our bases to base 10 or to ln base E. So again, instead of variables, if we have actual digits, this is what it will look like. We will take our log argument, 81's our argument, log argument goes on top, and 3 is our base, so log 3 on the bottom. Again, we have hidden bases. Our hidden bases are 10s. Okay, that's going to give us a 4, and hopefully at this point we all know that 3 exponent 4 is 81. Let's move on to a couple more examples. If I take a look at the next example, I've got log base 4 of 1024. Now again, I can solve this a couple different ways. I can change 1024 into a base 4, which it is. However, it wants us to use the change of base identity. So doing the change of base, I'm going to be actually taking the top log 1024 and dividing it by log 4. When I do so, you're going to get the answer of 5. So A gives us an answer of 5. When I take a look at B, I have a fraction there, so I need to put it in brackets, and I need to put that 3 on top as an exponent, and then I'm able to solve it. Or I can actually put the 3 outside the side, and I can times it by my answer. So I can write it down a couple different ways. This is what it would look like. So the one way, leaving the 3 out front, I'm going to have log of 1/1000 dividing by log 2. And then again, I'm going to times my whole answer by 3 in the end. Don't forget, yes, brackets are necessary. Okay? When I solve B, I'm going to get a decimal answer of -29.90. It says hundredths, so I need to show that 0 there. Okay, now I could have also put that 3 as an exponent up here instead of actually timesing my whole answer of 3. I would get the exact same answer. Let's take a look at C. Okay, for letter C, we're going to have, first of all, we're going to deal with this exponent part. So I'm going to take log 216 and divide by log 6. When I do that, I'm actually going to get 3. Now that is the exponent. That's what this part equals is 3. I still have a base of 6. So now I need to solve. It's 6 exponent 3. Well, 6 exponent 3 is going to give me 216. So the whole expression there on letter C solves to become 216. Let's try D. Can we use it in the root sign? Yes, we can. Okay, let's take a look at D now. D, we're going to have log of root 1/1024 divided by log 2. Now remember, it's going to open brackets. Log will open brackets, so yes, you need to close the brackets on top, and yes, you need to close the brackets on the bottom. Now, some calculators also open a bracket under the root sign. If your calculator does that, that means you have to double bracket the back here on this one, because you have to close the bracket on the root sign, and then you need to close the log bracket. That's how that works. Okay, that one is going to solve and give us an answer of -5. You guys try a couple on the bottom. When you get stuck, let me know and we can do some of this together. Okay, taking a look at the bottom, we're going to take log 8 divided by log 2. That's going to give us 3. Again, we're using the change of base identity. We know that 8 is also a base 2, so I could have done it this way with log laws. Log base 2 of 2 cubed. My base and argument cancel, and I get 3 for an answer. Yes, I can solve it that way, but that's not what it's asking me to do. It wants me to use change of base, so that means you must do it the way that is written there above. Okay, let's try with letter B. Yes, again, brackets are necessary. So I'm going to have log of 1/7 divided by log 7. When I do so, B is going to give me -1 as an answer. Try C and D and see what you get for answers. Again, yes, the brackets are necessary. So when you have fractions, you definitely need to have brackets. Okay, D is going to give us, C first is going to give us log 8 divided by log 64. When we solve that, that's going to give us an answer of 0.5 or 1/2. When we solve D, we're going to have log of 8 over 125 dividing by log 2 divided by 5. We solve letter D, and we're going to get an answer of 3. Check your work and make sure you did it correctly. Okay, moving on. Letter E, we're going to take 4 times the whole answer of what I have here, log 0.001 divided by log 10. And yes, of course, they have brackets. You don't need to put the big brackets the way I have. I'm just showing that you must solve this part first and then times by 4. Okay, when we solve letter E, we're going to get an answer of -12. Let's take a look at letter F. Again, letter F has an exponent that's in log form. So we're going to solve that exponent and then put the exponent back on the 6. So I've got log 36 dividing by log 6. That's going to give me a 2. Now I put that 2 back on the 6, so I end up with 6 squared. My full answer for F will give me 36. Check your work. Moving on to letter G. Letter G is a little bit bigger, so it's going to require a couple more steps. We need to solve the left-hand side of the subtract sign, solve the right-hand side of the subtract sign, and then subtract both those answers. So that's exactly what we're going to do. Solving the left-hand side, we're going to have 3 timesing by log 10 dividing by log 1/10. But again, yes, you need your brackets. The left-hand side here is going to give me 3 times -1. My 3 drops down here. This becomes -1. 3 times -1 gives me -3. That's the left-hand side of my equation. I have my subtract sign that comes down, and then I'm going to solve the right-hand side of the equation. So this right-hand side, we've got 2 timesing by log of 1 over 100 dividing by log of 1/10. We're going to solve the log part times the answer by 2. So I'm going to get the 2, and this becomes 2, the answer of all this log stuff. So I'm going to take my 2 times 2, and I'm going to get a 4. So that means my final answer here, when I solve the expression, I have the left-hand side subtracting the right-hand side. So I've got -3 subtracting -4, -3 subtract 4 is going to give me a total answer of -7. So that whole expression solves to be -7. The next section is the student practice section. I will give you the answers for these. If you have problems solving these, please come see me and I can give you a hand. Here are the answers. 1A is going to give us a 2. B is going to give us 3. C is 6. D is 1. Letter E is 3. F is 2. G is 0.5. And H is 0. On the next part, number 2, A is 1.76. We want 2 decimal places here. B gives us negative 2.56. Yes, we can have negative answers. Letter C gives us negative 3.10. Yes, I need to show the 0 because it wants hundredths, 2 decimal places. D is going to give me negative 1.44 as an answer. And letter E is going to give me 1.46 as an answer. Looking at number 3. A is going to give me an answer of 0.5. B gives you 3 over 2, or 1.5, that is equal to. C is going to give me an answer of 2, and D is going to give an answer of negative 2. Ordering from least to greatest, the way this should look is log base 9 of 1/3 is your least. This gives you negative 0.5 as a decimal. Then we get log base 16 of 1/2 as a decimal. That gives us negative 0.25. The next one is log base 5 of 1. That gives us 0. The next one in order least to greatest is log 10. Log 10 gives an answer of 1. And the very last one is the largest, and it is log base 2 of 16. That answer is 4. So this will be on the other side here. It is the largest. Okay. Moving on to the next practice section. A is going to give you an answer of 5. B is going to give you an answer of 1/9, or 3 to the negative 2. C is going to give me an answer of 5 over 8. D is going to give an answer of 4. On this one, this guy gives us an answer of 4. This one gives us an answer of 10 cubed, which is 1,000. Okay, the last couple regressions here you have. This example, we get our parameters, the equation again, to the nearest thousandth means we want 3 decimal places. So we get our equation being the A value, negative 305, pardon me, 0.089 plus 34.967, and that's all in front of the word ln, and then we've got our x. That's how we write that equation. Check your work. On the next equations, we have 2 more to look at here. Oh, and back at the first one, was it an increase or a decrease? What was this guy actually doing? This one was increasing, okay? Our next 2 examples, also both increase. Let's take a look at their equations. So, example 2 is going to give me an equation of y equals 0.037 plus 23.872, and again, I put ln x at the end. The third one, equation for example 3, is going to give me an equation of y equals negative 558.521 plus 55.633, and on the end of that again you're going to have ln x. Okay, ln x goes at the end there. So right here you go, ln x at the end. Okay, check your work. That concludes lesson 1.2, 1.2b, change of base.